What if the solution to powering Boeing 747s without destroying Earth lies 8 kilometers underground? Global logistics and heavy industry, accounting for a quarter of global CO2 emissions, are at a standstill in the race to net zero. While passenger cars can easily go electric, the same isn't true for a Boeing 747, a cargo ship, or a 400-ton mining truck. These hard-to-abate sectors require an energy density that current batteries simply cannot provide. To achieve net zero by 2050, we don't just need to stop emitting CO2. We need a way to keep these industries moving without destroying the planet. Currently, heavy transport remains tethered to fossil fuels because there is no viable, high-density alternative that fits existing infrastructure. Fuel-powered heavy-duty engines in aviation, marine freight, mining, agriculture, construction, and large trucks are difficult to decarbonize through full electrification. At Aches Green Energy, we have developed a closed-loop system that treats CO2 not as waste, but as a feedstock. Our technology works in 3 integrated stages. Stage 1, green hydrogen via Mechanocat ALSs. Tidal mechanical energy drives room temperature water splitting with floating solar thermal conditioning. Mobile units condition seawater and harvest hydrogen continuously. Stage 2, subsurface synthesis in ultra-deep wells. Captured CO2 reacts with green hydrogen to form methanol about 8 kilometers underground. Methanol is isolated and injected into a second well, converting to dimethyl ether. At DME saturation, gas is released through a heated external casing at 350 to 500 degrees Celsius and 1 to 3 bar. Here, methanol, or DME, rapidly convert into light olefins. Stage 3, oligomerization in a third well. At 20 to 60 bar and 200 to 350 degrees Celsius, olefins oligomerize into longer hydrocarbons. The emerging hydrocarbons are pumped to surface for finishing. One plant converts linear olefins into branched isoparaffins to improve diesel cold flow. Another converts linear olefins into cyclic hydrocarbons to meet jet fuel density and freezing point specifications. Result: longer-chain hydrocarbons suitable for drop-in diesel and jet fuels. These fuels fit existing engines and infrastructure, all from CO2 and water into high-performance drop-in diesel and jet fuel. What makes us innovative is our subsurface chemical engineering shifting the energy burden from the electrical grid to the Earth's core. Every individual stage of our process has been successfully validated at laboratory scale. We are currently at TRL4, having proven technical feasibility of the integrated components in a controlled environment. We are now moving toward pilot-scale integration, finalizing the engineering for our first deep well injection site to prove that we can balance the scale of human fuel consumption with nature's own recycling capacity.
Recycling CO2 into renewable diesel and jet fuel offers major benefits. It's a drop-in solution for hard-to-electrify sectors like aviation, shipping, mining, agriculture, construction, and long-haul transport. This fuel works without engine modifications, preserving performance while reducing life-cycle CO2 emissions. The global market exceeds $35 billion annually, growing at approximately 15% per year. Partial adoption could deliver major CO2 reductions. Aviation could avoid 360,720 Mt CO2 per year. Heavy diesel sectors, 701,800 Mt per year. And marine shipping, 189 Mt per year. In total, these sectors could avoid or recycle 2.7 billion tons of CO2 annually. This establishes a closed carbon fuel cycle capable of recycling more than 1 billion tons of CO2 per year.
Our multidisciplinary engineering team has strong hands-on experience in plant design, energy systems, and automation. Amable Ngendahayo, our plant engineer, leads processing plant engineering for efficiency and scalability. Gerard Ndikumana, our founder and CEO, drives the company vision, technology integration, and commercialization with a focus on sustainable systems. Aline Abamana, our automation engineer, leads plant automation, optimization, and data-driven operations. Together, we deliver scalable, efficient, and sustainable industrial solutions. We expect the team to grow after our feasibility study and capital raise. Key hires will include a biochemical engineer, financial accountant, and HR officer.